In previous video, we have talked about various operations on the set. In this video, we will talk about various properties of the set. Some of the properties are listed here, which we are going to discuss. Involution, commutativity, associativity, distributivity, absorption, tautology, identity, De Morgan's law, law of contradiction, and law of excluded middle. I'll make sure that you understand it in proper way with examples. The first property is involution. So if we take complement of complemented set, then that will result into set itself. That is, A complement would be A. On right hand side, we have taken some data where set A contains 1, 2, 3, B is 2, 3, 4, C is 5, 6, and universal set X is 1, 2, 3, 4, 5, 6. Let us compute complement of A. So that is X minus A, which is 4, 5, 6. And let's take complement of that. So that is A complement of complement. So again, we have to subtract that A complement from the X, which will give 1, 2, 3, that is set itself. And hence, involution property is proved. Commutativity says A union B is same as B union A. So if we first compute A union B or we compute B union A, both are same. So commutativity property is hold for union operation. Same way, it is true for intersection as well. So if we compute A intersection B or we compute B intersection A, results would be same. Associativity, A union B union C is same as A union B union C. So either first we calculate union of A with B and then we take the union of that with C would be same as if we first compute B union C and then we take union of that answer with A. In both the case, output is not going to change. So union is associative operator. Same is true for the intersection. So either we compute A intersection B first and then we take intersection of that with C, which is phi in our case, would be same as first we compute B intersection C and then we take intersection of that with A. So that is also phi. So both answer proves that intersection is also associative. Law of distributivity, A union B intersection C would be same as A union B intersection A union C. Let us first compute left hand side of the equation. So B intersection C is phi and union of that with A would be 1, 2, 3. So that 1, 2, 3 set is the output of left hand side of the distributivity law. Let us compute the right hand side of that. First we'll compute A union B, which is 1, 2, 3, 4. A union C is 1, 2, 3, 5, 6 and intersection of that is 1, 2, 3. And we can verify that answers of both the sides are same and hence this rule is true. Same it is true for intersection as well. So A intersection B union C is same as A intersection B union A intersection C. Let us prove it with the data. For computing left hand side, first we'll compute B union C and then take intersection of that with A, which is 2, 3. For right hand side, first we'll compute A intersection B, then A intersection C, and we'll take union of both. So that is also 2, 3. And from the answers, we can say that law of distributivity is true for intersection as well. Absorption, A union A intersection B is A. So A intersection B is obviously a subset of A. And when we take union of any set with its subset would be larger set only. And let us try to prove it with the example. So A intersection B is 2, 3, which is definitely a subset of A. Right? We can see that 2, 3 is present in set A as well. So when we take the union of that with set A, so that will be original set 1, 2, 3, that is A itself. And A intersection A union B is A. A union B is superset of A. And intersection of A with the superset of A would be definitely set itself. So that is also A. Let us compute A union B, which is 1, 2, 3, 4. And we can see that A is subset of A union B. And when we take intersection of subset with its superset, then output would be subset only. So that is A. Idempotency or tautology, when we take the union of set with itself, will be set on or original set only. Same way, when we take the intersection of set with itself, all elements would be common and that will result into the same set. Identity says A union X is X. So as we talked earlier, A is subset of X. And when we take union of subset with its superset, then output would be superset only. A intersection X is A. A is subset of X. And when we take intersection of subset with its superset, then output would be subset. So that is A in this case. A union phi would be A definitely. And A intersection phi would be phi because there is no common element. De Morgan's law we have already talked in previous video, but let me recap it. A union B complement is same as A complement intersection B complement. So A union B would be 1, 2, 3, 4 and complement of that would be 5, 6. Let us compute on right hand side. A complement is 4, 5, 6. B complement is 1, 5, 6 and intersection of both is 5, 6. So that says that LHS is equal to RHS. The second rule of De Morgan is A intersection B complement is same as A complement union B complement. Let us compute A intersection B first, which is 2, 3 and complement of that is 1, 4, 5, 6. A complement is 4, 5, 6. B complement is 1, 5, 6 and union of both is 1, 4, 5, 6. So here as well we can see LHS is equal to RHS and hence De Morgan's both laws are true. Law of contradiction says A intersection A complement is phi. So very obvious because A complement contains all the elements which are not in A. So there will not be any element common between these two sets. So when we take the complement, when we take the intersection, obviously that will result into null. A complement here is 4, 5, 6. A is 1, 2, 3. So when we take the intersection, that would be null set or the phi. And law of excluded middle says A union A complement is X. So that's also very trivial. A complement is all the elements which are not in A. So when we take the union, it will form the universe of discourse which is capital X. So here A complement is 4, 5, 6 and when we take the union with A, that would result into 1, 2, 3, 4, 5, 6 which is nothing but our universal set capital X. Let us test your knowledge. Let A is equal to ABCDE and B is equal to EGI. Prove the De Morgan's law for given sets A and B. So you have to prove both the laws of De Morgan's. Question 2. Find the power set of set B in question 1. So you have to list out all the subsets of capital B. Find universal set for question 1. Next question. Prove law of excluded middle for set A and prove law of contradiction for set B. Please mention your answers in comment box. If you have any query or any confusion related to answers, you can visit the link given in the description box where you can find all the answers of all the assignments or the questions given in this video tutorial. Thank you. That's it for today folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.